Hello and welcome to this session in IBDP MAI HLSL course. And today we are going to talk about optimization problems, where we will try to maximize profit or minimize cost or a given function actually. They will give us a function and we have to maximize or minimize that function. Okay. So for that I will use the first derivative test. Remember, let's consider a is the function which is to be maximized or minimized. You need to convert it in terms of one variable. That's very important. Convert in one variable the function which is to be maximized or minimized. Then you can find the derivative of that, right, which is the a prime, which gives us the slope of tangent lines. After that, for finding the critical points, you can substitute a prime equal to 0. So from here, you will get values of the variable. Say x is your variable, so you will get some values of x. You may end up getting 1 or 2 or whatever it is. So let's say x1 and x2 are the values or critical numbers. Then we can draw the sine graph for the a prime. Okay, means we will check what is the sign of a prime in that interval, say x1 and x2, or let's say 3 points are there, x3. Okay, so first we will check what is the sign of a prime for the values left to x1. Let's consider it comes out as positive, this comes out as negative, this comes out as positive, and this comes out as positive again. So you know that the nature will be something like this. It is increasing here up to x1. Then after x1, it starts to decrease, right? And from x2, it again starts to increase. And after coming at x3, again it keeps increasing. So we can say x3 will be the point of inflection, x2 is the point of local minima, and x1 will be the point of local maxima. So I will use this thing to calculate the point of maxima, minima, or point of inflections. Okay, so let's take a problem. It says a rectangular cake dish is made by cutting out squares from the corners of a 25 centimeter by 40 centimeter rectangle of tin plate. Here you can see this. Originally, it was a 25 by 40 sides, right? So then they says we need to cut the squares and fold this in order to make this container without top, you can say. Now it says what size squares must be cut out to produce the cake dish of maximum volume. So the important thing is we are trying to maximize the volume. Automatically you will get maximum volume, by the way. But okay, look at this function. Volume is to be maximized. So let's consider the volume function is given by V. But the thing is, first let's consider what size of square is cut out from each corner. So we have this rectangular sheet and squares of side length, let's say x, we cut out, okay, from all four corners, x, x. Okay, so if this length was, let's say, 25 centimeters, so now this part will remain 25 minus 2x only. Similarly, if the entire this side is 40 centimeter, so this portion will be 40 minus 2x, right? Okay. Now let's find the volume. It's a box without top. So it is a cuboid actually. So now the volume, let's call it V, is given by length into breadth into height. Here the length part is what? 25 minus 2x. Okay, this side will be, if you fold this, you will get 25 minus 2x as the length. And the breadth will be 40 minus 2x. And the height will be same as the square size, right? Because you have to fold it, right? So you are folding along this. So this will be the height, which is x. So height is x here. So that's your expression in terms of v only, right? So now here we have x as our variable. So let's simplify it because we have to differentiate it. So you can multiply the terms and get the value of v. It comes out as, let's multiply these. So we will get 25 minus 2x multiplied by this 40x minus 2x squared. Further simplify this and let me write the value. It comes out as, after simplification, 4x cube, then minus 130x squared plus 1000x. That's the volume expression in terms of x. Now for the second step, we need to find the v prime, means take the derivative of this. So use the derivative formulas. It comes out as 4 times 3, which is 12x squared minus 260x plus 1000. Now we need to find those critical numbers where the function can take maximum or minimum values. So put v prime equal to 0 for the critical points. It gives us 12x squared minus 260x plus 1000 equals to 0. Now you can use quadratic solver, right? In your GDC, it's a quadratic equation. You can use the quadratic solver to get the values of x. So from here, using my GDC, I'm getting the values of x as 50 by 3 and 5. 50 by 3. If I take multiplied with what 2, that's x value. Okay. So let's see, 50 by 3 multiplied by 2 gives 100 by 3, right? Which is around 33.3 something. So is it possible to have this value? No, that's not possible. In that case, see this side, what will happen to this side? It will become negative, which is not possible, right? So 25 minus 2x will become negative for that case. It means we can say 50 by 3 is not possible. We have only x equals to 5. So let's draw the sine graph for v prime. 5 is the point. Now for the values which are left to 5, you can choose any value, say 4, and put here. Find the v prime 4 and also find the v prime 6 and check the sign only, whether it comes out as positive and or negative. Okay, and once you do this, you will find that it comes out as negative for v4 v prime 4 and positive for v prime 6. Okay, it means the function is decreasing here, and sorry, it is positive here, and sorry, it is negative here. Okay, it means the function is increasing for the values less than 5, and after 5 it starts to decrease. So it will be something like this. The graph will be something like this, which shows there is a local maxima. Local maxima at x equals to 5. And if they say find the maximum volume also, but in this question they are not asking for the maximum volume, but by the way, if they ask for maximum volume also, Vmax, that will be the V value when x equals to 5. So directly substitute x equals to 5 in the volume expression here. Okay, that comes out as, I already calculated that, once you put x equals to 5, you will get 2250 cubic centimeter is the maximum volume which is obtained when you cut out squares of side length 5 centimeter from each corner. Then you will get maximum volume of the box. So you will get these type of questions only in this part. So I'm giving you a homework question. Please try this question all by yourself, and I'll see you all in the next session. Thank you for watching this. Keep watching, keep learning.